Bulletproof Radio, a state of high performance.
You're listening to Bulletproof Radio with Dave Asprey. Today is a special live recording. You may hear the ocean in the background because I'm here at the X Prize event, which Bulletproof is sponsoring. And I got a chance to interview Dr. Bob Hariri, who is an amazing human being, a personal friend, and someone who just got off stage. He's got 30 years as a neurosurgeon and a medical entrepreneur who's done a huge number of startups innovating at the very forefront of how we can get control of our own biology, both medical stuff and now some things that are quasi-medical that are tied to anti-aging, longevity, and stem cells, particularly a company called Cellularity, which is pioneering some of the new ways we can live a lot longer than we thought we could. Bob, welcome to the show.
Dave, it is, as always, great to see you, and thanks for inviting me.
Bob, on stage here with Peter Diamandis, you just talked about some incredible things that you think we're going to be able to do over the next even 10 years to radically extend what we'll call the human health span. And you said something that really caught my attention. You said 100 is the new 60. What does that mean?
You know, Dave, we have been working for more than the better part of 2 decades on turning living cells into medicines. And on that journey, we recognize that the way a stem cell exerts its biological power when used as a therapeutic is to, in essence, reprogram a system. And that's really useful when we're trying to go after cancer by using immune cells that can specifically target, identify, and destroy a cancer cell. It's useful when we use these cells to modulate the immune system, to turn off inflammation or to turn off autoimmunity. But it's also really valuable if you want to change an aging phenotype, an aging form, into a more youthful form. And so I became curious about this maybe a decade ago and started to study some simple relationships, the number of stem cells in your body as a function of age, and whether the stem cells in your body decline qualitatively as well as quantitatively with age. And lo and behold, that's what we've actually shown. So the obvious next experiment to do was, if you're losing stem cells as you age, and that's one of the reasons why you develop the symptoms of aging, why not give yourself stem cells back and see what happens? And some of the early work was really compelling. We showed that in experimental animals, the number of stem cells in every organ and tissue decline with age. And if you replace them, you can actually extend the lifespan of those animals. So where this is taking us in the future is where we want to develop a toolkit that would allow us to safely, reliably, and repeatedly boost the regenerative reservoir that resides in our body by getting a dose of cells that literally restore this youthful phenotype.
4 years ago, I had my first stem cell treatment where Dr. Harry Adelson pulled some fat out of my own sort of lower back area, made some stem cells from it, or more likely extracted them, and then injected them intravenously into some sites of injuries I had, and they all went away. All the areas of pain stopped. And since then, I've done a ton of stuff, and I haven't tried the things that you're making yet, which I'm excited to do. Maybe 2 weeks ago, I had a half a liter of bone marrow pulled out through both hips, and we used that in every joint in my body and things like that. But this stuff is relatively expensive. And one of the concerns that I have is that right now, this is cheaper than joint replacement, and it might prevent it. So it's actually, if insurance would cover it, it's actually a better use of funds, and you don't have to have replacement parts, maybe, which is a good thing. But when is the stem cell universe going to be open to all of us versus just the people who can afford it now?
So first off, Dave, I've known you a long time, and you're as tough as nails if you had a half a liter of bone marrow collected, because I know that's not fun.
We blended it with coffee and I drink it right down.
Another great product line. So you're hitting on some very important points. First and foremost, the answer isn't going to be harvesting your own cells via a surgical extraction. The answer in this field is going to be who can productize an allogeneic, off-the-shelf cell that can be produced to the high standards of a pharmaceutical and is one size fits all. That's actually where we are at Celularity. So Cellularity is the company that pioneered the use of the leftovers from a full-term healthy pregnancy and isolating the cells from that organ to do all of this. Here's the cool thing, Dave, and you'll appreciate this. The challenge early on in cellular medicine is, could you find a cell that could be delivered to a recipient without having to go through the exhaustive effort of matching the donor to the recipient the way we do for organs? But here's the thing. Nature did the work for us already. The placenta is nature's professional allograft, which means it's designed to exist in an unrelated recipient without the need to match. Think about this, right? A mother contributes 50% of the DNA to the fetus she carries. Yet for 9 months, she doesn't reject it. It doesn't reject her, right?
Yep.
Think about surrogate pregnancy. The mother's not even related to the fetus. She contributes no DNA. She's completely unmatched to the tissue type of the fetus, yet she carries it for 9 months, doesn't reject it. It doesn't reject her. The underlying biology behind this is one of the most powerful tools we are incorporating in our entire therapeutic strategy. So stem cells from the placenta are naturally allogeneic, and it means you don't have to harvest your own cells, which, by the way, this isn't any kind of a knock on you because you're one of the healthiest guys I know. But as we age, we damage our own stem cells in our fat tissue, in our bone marrow, et cetera. The stem cells that come from a newborn are pristine. They are in the best biological state there will ever be. So stem cells from a placenta will always have qualitative advantages over cells recovered at some point in your life.
Oh, yeah. I'm 45 and I used to weigh 300 pounds and I had all sorts of autoimmune conditions. And I've had some hard living, especially in the first half of my life. And I'm sure that that's reflected in my stem cells, probably even in the number of DNA mutations I have and things like that. So I'd rather get fresh stem cells. And frankly, I've had my bone marrow tapped now a couple times, and having the kind of liposuction, which isn't cosmetic, but where they just pull fat out. It's about a coffee cup's worth of fat. It's not a really fun procedure, to be honest. And what I got from that was definitely matched stem cells, but I got 45-year-old stem cells, and I would have rather had 0-year-old stem cells.
That's right. And since you and I didn't have the benefit of storing our stem cells from birth, today our kids have an opportunity to do that, and that's going to be very, very important going forward. But the beauty of placental cells is that we can administer them to unmatched recipients safely and effectively. And not only do they create a state of tolerance in the recipient, but because they're younger and because they have biological properties of young cells, there are significant advantages.
Why do we have to go out and get placental cells from fresh placentas when we can grow a cell line in a lab? So you could just get one placenta and grow it and make hundreds of millions of doses from that, right?
So the beauty of the placenta is it is a robust source, economical, highly scalable. It can be subjected to very rigorous criteria for inclusion and exclusion. But the reason that we don't want to take just one source and overexpand it is the same reason why cells at 45 might not be qualitatively as good as they are early in life. There is a natural, for lack of a better word, exhaustion of the biological potential of cells as we continually call upon them to divide and expand. We've shown this in the laboratory. In fact, it's a basis upon which our manufacturing methodologies have been created. In order to preserve the highest quality of the cell, we limit the number of times we drive that cell to divide.
Okay, so the idea is stem cells that have been replicated over and over and over may basically age in a petri dish,
exactly,
or a bioreactor.
That's a great way of looking at it.
Now, are there any ethical concerns? There's been, going back to the very early days of stem cells, people thought they came from abortions and things like that. and I know that these don't. Can you walk me through the ethical and moral considerations that you went through with Celularity to figure out, how do we get these placental cells?
Absolutely. And in fact, that's one of the fundamental questions I asked myself back when I began the company. At a time when most of the work was being done around stem cells recovered from discarded embryos or abortus material, there was an enormous debate. There was an underlying tone of controversy, which put a tremendous risk on the entire field. Now, at that time, and I don't want to get into my personal religious or my personal morality, but I felt it was fundamentally flawed to rely upon discarded embryos and fetal material, because you could always create a very perverted incentive to go after that. But staring me in the face, and I have to thank my oldest daughter. My oldest daughter, who's 27 now, she's a Princeton graduate, has spent time at Oxford and Georgetown, and now is getting her MBA at Wharton. When she was in utero, she taught me that the placenta was basically nature's stem cell factory. And since we throw that factory away at the end of every birth, why not just go harvest these? So number one, it's abundantly available. To use our buddy Peter's great terminology, abundance is important here. That's number one. Number two, and this is really critically important, the fundamental choice for a parent to donate this material for these purposes is left completely up to them. So we collect these placentas to isolate cells and biological materials under full informed consent, giving the family the option to choose whether or not to do this based upon their own personal altruistic interests. Now there's an opportunity in the future to be able to reward donors of this material by providing them access to some of the materials for their own purposes. But I will tell you, in 20 some odd years of doing this, it is a rarity that a family says, no, I would rather you incinerate the placenta than use it for something meaningful. There's a fundamental altruism that exists in the period around the birth of a healthy child that we have just the world is a beneficiary of.
So you could basically help someone who has Alzheimer's or some sort of traumatic injury or something, or you could just throw it away, and that does make sense. Are you concerned that maybe cells have consciousness or anything like that? I mean, I've heard some people who just on social media and whatnot on Instagram will ask questions like that. Are you worried you're putting some other cells in your body? What's your just overall thinking about this? Isn't your cells? Are they going to stick around and be a part of you?
You know what? That's an interesting question. Look, every living cell contains its own biological software written into its DNA.
Right.
And so the DNA from a donor placental cell is different than your DNA. Okay. And when that cell takes up residence in you temporarily or permanently, that new code, that new biological software has to coexist with your biological software. Now, people don't realize that, but that's a fundamental biological principle. Okay. I will argue to you today that chimerism, the ability of another genome to coexist in a different organism, is one of the fundamental biological principles of mammalian biology. Okay, think about this, right? Any placental mammal that produces more than one offspring actually exchanges cells between offspring between one another, and this microscopic chimerism, this multiple genomes in the same organism, is not only tolerated, but it probably provides certain benefits. So let's think about this, right? And you know this world very well. In agriculture, chimerism, right? Grafting together tree branches in order to create higher virulence and higher virility and higher disease resistance is a common practice. Chimerism has a therapeutic advantage, and I've actually had a principle called chimeric vigor, which we are actually working to develop. Think about it this way. You know what hybrid vigor is?
Yep.
Hybrid vigor, when you have two distinct parental genomes that come together to create offspring. Those genes recombine and select in order to provide advantages to the offspring. right? It means your offspring should be better than you, healthier, et cetera, et cetera. That hybrid vigor occurs between generations. But if I take stem cells that have a genome that have certain biological properties that are advantageous and put them in you, those traits will get upregulated and expressed if it provides you a survival advantage. Chimeric vigor can occur within a generation.
So I want stem cells from Wolverine.
Exactly. Hey, listen, buddy. The truth of the matter is we are embarking on an era where we can quality check stem cells. We can understand the underlying biological software and select traits that, when conferred to a recipient, improve the health of that recipient. That's work that we're working on today. So yeah, I mean, there's going to come a point where you can maximize your health by expressing those biological traits that give you certain selective advantages against disease.
It may sound weird, this idea that you can have other DNA inside you, but there are studies, a lot of people don't know about them, that show that every time a woman has sex with a man, she gets a little bit of DNA from the semen that permanently resides in her system.
Either permanently or transiently. And by the way, multiparous women who have multiple children, will carry cells from every child in their body for their lifetime. So pregnancy and carrying children creates what's called multiple mixed microscopic chimerism, and it is very tolerated.
There are also mitochondria, which is a big focus for my work on my last book, Headstrong, where you look at this different DNA source, which is the mitochondrial DNA that programs the power source in your cells. When you get stem cells from a donor, are you going to get those mitochondria? Will they take up residence in your system? Will they talk to your mitochondria? Will they change your mitochondrial genome in addition to giving you new cells?
So the mitochondria resident in the cells administered to you remain resident to those cells. Okay. And so you do get the advantage of mitochondrial chimerism as well. And if that provides certain biological advantages, that will naturally get upregulated and expressed.
There are questions around whether stem cells that get administered intravenously or injected somewhere, whether those cells go in, secrete healing factors, and then die, or whether they actually become new tissues for you. What has your research shown you? So,
good question. Most of the work today suggests that stem cells exert their biological properties by transiently affecting the secretome of the individual, contributing synthetic products to the or synthesized products to the individual, and then moving on, dying off, and not being a permanent resident. Now, the truth of the matter is we don't have tools today that allow us to measure microscopically single cell or small cell clusters in the body. It's very, very tough to do that. So I bet that even in what we think is transient cell therapy, there's some residual cellular material, but it's not necessary to exert the biological effects. And one of the beauties of a placental cell therapy strategy is these products can be re-administered. I actually envision that our form of cell therapy will be delivered in a linear fashion, serially, to continually get the biologic response you want.
How often do you get stem cells?
So you know what? We're working right now on developing a strategy to deploy these in a network of research clinics that will be abroad as well as in the United States. I've been working with some factors from stem cells, which I've administered to myself, placental exosomes, for example. And I'm excited about being one of the recipients of placental cells in our research network.
How often?
You know what? I actually believe that for the kinds of applications I'm interested in, extending the healthy human lifespan, you can administer these things safely on an annual basis or semi-annual basis.
I do it every 6 months.
I think, that actually, to me, everything we've seen, that goes along with the pharmacokinetics, if you will, of cell therapy. So I think you're making the right choice.
The last big treatment that I did, which was probably one of the biggest single treatments all at one time, I had very large numbers of cells, and I had 10 vials of placental exosomes all at the same time, which is, as you know, a very high dose.
Big dose, yeah.
And that was only a couple weeks ago, but I'm already feeling pretty good. I was a little out of it for a day or two, as you'd expect afterwards. I'm looking at how do we make this so all 300 something million people in the US can get access to it. How rapidly, what does it cost now to do a baseline Celularity treatment, and how far down do you see it going in 2 years, 5 years, 10 years? Is this a cell phone situation where they're 20 grand now and they're $1 20 years from now?
Absolutely. There's no doubt that this is a technology that will be introduced at costs that will be most approachable by people with high amounts of discretionary income, right? Then it's going to wind up trickling down. Like any breakthrough technology, there's a segment of the population that subsidizes the democratization of the products, right? And there's nothing wrong with that. People shouldn't think that this is a technology that's exclusive or elitist or whatnot. That's not the objective here. The truth is that because of what we've built at Cellularity, these are going to be very affordable therapeutics. What we need to operate within the confines of the regulatory community so we can get an unimpeachable data set showing intrinsic safety. And then once you have that, the clinical and regulatory and scientific world becomes more comfortable with using these products in conventional applications, sort of the common applications, dealing with age-related frailty, human performance, injury repair, et cetera. Look, I envision a time in the next 10 to 15 years where cell therapy is no more expensive than any traditional way we deal with inflammatory disease or cancer, and will be far more effective and far safer.
I absolutely love that answer. And there's a lot of skepticism from people saying, this is for rich people. Here's the deal. You go back, Craig Venter, a guy that we both know, he spent $100 million sequencing his own genome. And I've had my entire genome sequenced 4 years ago for $1,500, and it's around $300 to sequence your full genome now. Right. This is in our lifetime, just in 20 years. So it's not that far-fetched to say, look, someone had to be the guinea pig, and I'm happy to raise my hand. That's what I do. And to say that the mission of doing this is to make it so that it affects all human beings, and that there's no reason that anyone would want to keep this here, because frankly, I'd rather spend $100 instead of $1,000 on keeping myself young, right? So would everyone. And I'd rather be able to do it for my parents and my fifth cousins I've never met, exactly. As well as everyone listening to the show. So you see that as inevitable, right?
I do, and I think it is a fundamental driver of every business in the space. Look, I'm very fortunate. One of my members of my board of directors, my vice chairman, in fact, is John Sculley, the former CEO of Apple. Okay, and we talk about this. John is one of the most brilliant creative leaders I've ever known, and he's been a tremendous mentor. And he's helped me understand that a noble cause, as he puts it, right? A noble cause, like what they did at Apple. Okay, the cost of introducing that first breakthrough technology was enormous, and the risks were completely borne by the developers and the companies who did it. But look what happened, right? It transformed the world by putting communications and intelligent systems in the hands of everybody. And the natural course of events is that the overall cost per capita drops and drops and drops and drops and drops, right? Everybody's got an iPhone, right? This is not inaccessible. We want to do the exact same thing with cellular therapy.
What are the things that are making it stay expensive longer than it should?
Again, the process of going through regulatory approval, it's drug development, right? The cost of drug development, because of the enormous burden of proof and evidence necessary to get the legal right to sell a product, is what keeps these things expensive and takes time to get them out there. Where I think we want to have an impact is we want to work with regulatory leaders and clinical leaders so that there's a greater comfort level with the intrinsic safety of this therapeutic approach. Cell therapy is very different than biologics and small molecules because we know they have a very high safety profile. And regardless of what people may think, because there's been some sensationalized report of somebody who went to a renegade clinic, a fringe clinic out there, and got treated with stem cells and something bad happened. The truth of the matter is, cellular therapy clinics are all over the place, and you don't see disasters reported on a regular basis because cell therapy is intrinsically safe. But it's our responsibility as players developing this to get the proof in the form of high integrity data so that our colleagues on the regulatory side, our colleagues at the academic institutions, our scientific colleagues believe it, have confidence in it, and eventually become advocates for this.
I was a strategic advisor to the first clinical grade stick-on, take-home heart monitoring back in the early 2000s, and designed a lot of the data processing for it. And that company had to leave the US in order to do its clinical trials. They went to Med City in India, they went to Singapore, and they were able to do things to prove that it worked at a much lower cost before they could do it in the US. And I'm seeing issues of national competitiveness where it's just so expensive and so slow to do things in the US that a lot of the most innovative things are happening in China. They're happening in Thailand. They're happening in India. And medical tourism is to the point where it's cheaper to go do things south of the border, for instance. Sure. Do you see this as a regulatory issue, as a political issue, as just what's the US going to look like 20 years from now if we keep restricting this?
So it's all of the above. All right. Look, you know what? Without getting into a political discussion.
I don't want to go there. Yeah.
We don't want to go there. But in an environment where you understand that regulations, initially the thought process behind a regulated environment is to ensure safety, right? And to ensure and to protect consumers. When those systems turn into a major impediment to progress, the public loses. So, we're already seeing I think the potential long-term benefits of a deregulation philosophy that it's encouraging companies to invest in R&D. I think in the last 18 months, the reinvestment into R&D by companies that have been unburdened by regulations, it's profound. Right? The same thing will impact healthcare and medicine. Look, when the mindset at an agency is safety above all else, people are going to die waiting for products to get approved, right?
Yeah.
So when you think about it, if someone is comfortable allowing a line of people to die because a therapeutic is not approved, because they're so concerned that if it was approved, one patient might die on the therapy, that to me is a little counterintuitive.
There's a word for that. It's called evil.
Listen, I don't disagree with you, but here's the point. The regulatory world could say, you know what? We understand what the mandate is here. So let's establish a fundamental threshold for a demonstration of adequate safety. Okay. And then let's put the tools back in the hands of the practicing physicians who, by the way, okay, I think it's a little offensive that in some cases, panels and committees of lawyers and policymakers are dictating what a highly trained physician or surgeon can actually do. Why not put that back into their hands, but insist that they elevate the integrity and the comprehensive nature of the data they collect on every patient? Let me give you an example, okay? The standard for getting a drug approved is a well-controlled, placebo-controlled, double-blinded study, right? And you need a few of those to get drugs approved. When you do that in the conventional system today, it ain't a replicate of the real-world experience with those products. When you put the products into the hands of physicians in real world practice, but just insist that the data be collected at high integrity and high fidelity so you can actually on a regular basis continually update what we know, you can envision a day where literally every label for every therapeutic product changes dynamically on the basis of ever increasing human experience. That's a system I think would be perfect. And it would give everyone comfort in getting products available to patients earlier.
The Hippocratic Oath says, first, do no harm. Is it time to upgrade the Hippocratic Oath to say, first, balance risk and reward?
I think the best docs out there do that, Dave.
They do.
I think that they say, you know what? There is no free lunch here. Everything has predictable and unforeseen risk. As long as you're capable of monitoring the effects of everything we do in the treatment of disease, and as long as that information is made readily available and disseminated quickly, we minimize the long-term distributed effect of a bad outcome, and we maximize the tools that we can use to treat patients.
What you're saying, in essence, is that every patient could be part of a broad experiment if we get the data, so that we learn over time.
That's what healthcare used to be. Remember, you go back 50 years, okay? How did a doctor make decisions about treating a patient? Based upon his experience using a treatment modality, and he, based upon 10 patients, 20 patients, 100 patients experience, made decisions about treating the next patient, right?
Right.
Okay. We don't do that anymore. What happens is we have pigeonholed physicians into treating patients on the prescribed methodology that's in a package insert.
From the 1970s.
The philosophy was from the 70s, and it still carries forward. But think about this for a second, right? You think doctors ever read that? You know who reads? Have you ever seen a package insert for a pharmaceutical?
Yeah.
It's enormous. You think doctors ever read that? Never. You know who reads it word by word?
Lawyers.
It is used for evidentiary purposes in litigation. That's what drives me crazy. Okay? Doctors need to be able to doctor. And we disarm them when we limit what they do on the basis of regulatory systems that don't take full advantage of the ongoing dynamic experience of a product and a patient.
How would someone listening to the show go about finding one of those courageous doctors willing to, in essence, risk their medical license to do the right thing for a patient? Is there a selection criteria that you would go through to find someone like that?
It's very hard to do it because you know what? Those are the guys who in order to stay within the confines of the regulatory environment and the law and so on and so forth, they practice medicine the way medicine is designed to be practiced today. But you'll find guys who are willing clinical investigators who go and work with the newest breakthrough therapies, and those are the guys who are trying to push the envelope. Listen, I think healthcare in our country is broken. I think that there's ways to improve it. One of the great ways to improve it is to properly utilize the information management tools and computational tools so that literally every patient on a therapy is contributing to a data set that is analyzed dynamically and feeds back into the underlying prescribing information, so that literally every patient is like you say, a participant in a grand experiment.
As a patient, I think it's equally offensive that, at least in the US, I'm not allowed to decide what therapy I want with or without a partnership with a physician. Where my body, my biology, my decision, it wasn't encoded in the Bill of Rights, but it seems like that's a basic human right. Is our own biological autonomy a basic human right, in your opinion?
That's a great and sort of provocative question, right? Look, I'm kind of a libertarian by nature, and the way I look at it, we live at a time where any patient's family has access to more information than I ever had access to when I was in the clinics 30 years ago. And people need to have an opportunity and a right to at least contribute to the decision making about how their disease is managed. Look, at the end of the day, the best patient is the most well-informed patient. We sometimes don't give people the opportunity to make those decisions. But look, there are changes at hand. The Right to Try Act, right? This bill that the president recently helped advance. I think that that's not a bad thing. I have had very sad circumstances in my own family where I know that there were highly experimental therapeutics out there that could have changed the natural history of a disease, but for fear of getting in trouble, we never got to use those therapeutics. And there are patients out there who are sitting, waiting, and hoping that breakthroughs get approved, but they have no control over that. I think that access to experimental therapeutics under the right circumstances in the right environment, especially if it can contribute to the data set, is a good thing for everybody.
I couldn't agree more. And it's sad right now that sometimes the knowledge of those isn't out there. But if you have terminal cancer, I know several people, and you probably do too, who are having insane results in early human trials or in animal trials or heck in petri dishes.
Right.
But if you've got 6 months left to live,
right,
then you should be absolutely allowed to say, you know what, I'm going to die anyway. I think I'm going to try because we'll learn something as I maybe don't die or
Absolutely.
I do die. And the fact that that's not legal right now, it fundamentally pisses me off.
It's disappointing that our global leadership seems to think that they're in a better position to dictate the end of life care for patients, and what they're actually losing is they're losing an opportunity to contribute important information that could change the course of how we treat diseases. So I'm with you. I mean, look, I believe that there's a whole array of disorders where there's lots of experimental things out there, and we could actually hasten the review process and potentially speed up the availability of these things if we let people be courageous participants in an ongoing research effort to advance the field. Like you say, there are cancers out there that are being treated with immunotherapy and other things. Give people access to it as long as that data is made available for the world to review.
When it comes to treating aging as a disease, and I don't necessarily see it as a disease, but it's definitely something that we can change. It seems like there's this huge universe of opportunities, and I believe that stem cells and related stem cell growth factors and all that are a fundamental thing for it. But we're dealing with an environment where, since aging isn't officially a disease, you're not even allowed to treat it necessarily. How do you navigate that path of saying, well, we're not really treating a sickness, we're just making you better, when that isn't a medical claim? What's your thought process look like, and how do you speak about that both to regulators and to people?
Dave, it's a very, very tough place to play. Many of us are fearful that our enthusiasm about moving the field will be interpreted or perceived as an attempt to circumvent the law, which clearly it's not, right? I mean, as a scientist, all I care about is getting to the truth as fast as possible. The reality is, we have an opportunity to partner with the scientific, clinical, and regulatory community to do things that don't get in the way of people's choices. And I think that there's going to come a time where some charismatic leader is going to say, no harm, no foul. If someone with a terminal disease winds up being a participant in the study of a breakthrough therapeutic, whether or not it impacts their disease, as long as the information can be utilized to make decisions going forward in the development of those products. And you know what? Here's the crazy thing, right? You ask the general public, an FDA-approved drug is going to work, right? And the truth of the matter is that the vast majority of approved drugs actually don't work in the patients they're prescribed in. Look at cancer drugs, right? Yeah. The typical cancer drug works in less than a third, maybe a quarter of patients they actually get prescribed for. It doesn't mean that they're not approvable, right? What it means is that there is such biological diversity that in my mind, as long as you equip the clinical community with the broadest set of tools and allow them to make decisions on what works and doesn't work in a more dynamic basis rather than prescribed in a defensive way, right? Doctors prescribe, in cancer, doctors follow protocols because as long as you follow the protocol, you can't get blamed if there's a bad outcome, right?
Yep.
So again, I argue that much of what we're doing in getting agents approved under prescribing information doesn't necessarily help the patients, but it does serve as a basis for the legal community to try and find culpability when an outcome that's not expected or unwanted occurs. I don't know if that's good for the public.
It doesn't seem like it is. Not even a little bit. So I'm excited for the world that you're talking about there, where a leader comes forth and says, we're going to allow experimentation. But you said that
and again, the connotation of the word experimentation always appears to be exploitive, right? Yeah. And the truth of we have to change it,
self-experimentation.
Right? Yeah, we have to. The truth of the matter is that people need an opportunity to test what works for them, right? No two products work the same. No product works the same in two different individuals, just like no medications.
Even no food works the same in two individuals, right?
So, listen, I think we're getting to a point where we're going to see an increase in the receptivity to do these sorts of things. I just hope it happens fast.
It will. And the second step of that is that life itself right now is a terminal condition. And that means once we open the door for people to self-experiment in partnership with technology and with physicians, at a very soon point after that, you say, well, wait a minute. I know it's going to happen 100, or in my case, at least 180 years out. I think I'd like to affect that now. And then self-experimenting can just be built into our ability to be human being. But there's a downside or a risk to this that I want to pick your brain on. We've talked a little bit about cancer. Anytime you increase regenerative capacity and growth in tissues, which you want as you age, you also could be running the risk of increasing the risk of cancer. Are you concerned as we push the limits of aging or healthy aging and as we cause cells to get younger, that it might change the risks of cancer? And if so, what do you do about it?
That was a very central early concern about the use of stem cells in medicine. Isn't a stem cell potentially an ignition source for cancer? In practice, that hasn't been the case. Okay. There has been an enormous number of recipients of some form of stem cell therapy, and there has not been an association between those products and an increased risk of cancer. The data is still being generated, but I believe that healthy stem cells from the right source, do not increase the risk of cancer. By the way, in some cases, stem cell therapy, because it helps support a healthy immune system, could in fact reduce the risk of cancer.
I've had my blood taken out and had my natural killer cells cultured and had about 2 billion of them reintroduced all at once, which is something that they do for cancer. I don't have cancer. I just want a really young immune system. And so there are some really cool things you can do if you're concerned about that. And I look at the data you shared in your talk here at the X Prize event, and you said something like 58% of people past 90 get Alzheimer's or cognitive decline or dementia. 58%. So if you have a 10% increase in cancer risk and a 58% reduction in Alzheimer's risk, I don't know. I'd sign up for that.
I think you're right. And I think also that if we actually uncover that cell therapy speeds up the development of a malignancy. That's the kind of information that, forewarned, will actually increase our vigilance.
Yeah.
And you could have the trade-off of you benefit one disease, change the dynamic or risk for another, but now at least you know what to look for. Remember,
Yeah.
cancer, when identified early, is curable.
Yeah.
Fundamentally curable, right? I mean, stage 0 cancer has one of the highest overall cure rates because you can excise in one way or another the core of that malignancy and eradicate the problem. But I mean, look, this is a big team effort that's required between all of the constituents here, from the patients to the basic scientists. I just want to make certain that we don't hamstring what might be one of the greatest therapeutic breakthroughs in history because of irrational fear and underlying political agendas, which confuse and confound the issue.
Bob, how long are you going to live?
You know what? Listen, I got 3 kids who are the absolute reason for getting up every day, and I hope that I'm around to see their children and maybe even their children's children. I think that with what we know today, someone like me could easily live to 90 to 100. Okay, I think that if some of the tools we bring to bear today get to the point where they're every day available, we could push that even beyond. But I do know that my kids are guaranteed to live to 100. And I believe that their kids have the potential to live to 120 to 150. And if our good friend Ray Kurzweil's right, and we reach that longevity escape velocity, we may actually be able to maintain a form of life well beyond even 150.
I think that it may happen faster than that. I mean, we're here with Peter Diamandis, the king of exponential technology and abundance and all that. And I look at my own experience with the internet. I helped to design the first provision on demand thing, which is a precursor to what we do with Amazon Cloud Services and all that. And you look at what happened in the course of our lifetime. You've got 30 years of clinical practice and starting companies. You've seen how fast things are changing. And if we change 10 times faster over the next 30 years, don't you think you're thinking small?
I'm being conservative because you're mostly held accountable for the bad predictions rather than the good ones, right? But look, I'm highly optimistic, and like you say, what the great thing about this kind of an environment for us, Dave, is we've gotten to know each other and build friendships and a fraternity here where we're with the smartest, most creative, most innovative, most enthusiastic people on the planet. So in this environment, I agree with you. I think we can step out of our comfort zone and say, you know what, 150 is an easy, achievable lifespan. So I'm with you, my friend.
Well, let's race, and I'm willing to die trying. It's totally okay.
Me too. We'll do it together.
We will. I have one more question for you. Someone comes to you tomorrow and says, Bob, I want to perform better at everything I do as a human being. Tell me the 3 most important pieces of advice you have based on everything you know. What would you recommend?
First and foremost, I am convinced that maintaining the largest healthy lean muscle mass is central to overall human performance, mobility, cognition, and aesthetics. So that's number 1. And there's lots of ways you can do that outside of the therapeutic realm.
Yep.
Okay. We need to do what nature intended, which is load our muscle and to permit our muscle to maintain its highest mass and health. The second thing is I want to avail myself of all of the breakthroughs in cellular medicine because I do believe that is one of the easiest tool sets we have out there. And then the third thing is there is a whole sphere on the intellectual and sort of emotional and spiritual side of things that's a contributor here that we have yet to fully understand. We saw some great talks today on how complex the brain is and how the interplay between the brain, immune system, and so on is ultimately programmable. right?
It is.
I want to stay in touch and tuned into that, because that's going to be a contributor as well.
It's one of the reasons I started a neuroscience facility called 40 Years of Zen, because I wanted neuroscientists to help me work on that, because we've shown, it was Candace Pert's work, the woman who discovered the first opiate receptor, that your immune system has its own memory.
Absolutely.
And that's got to be hackable.
That's right.
Right. Well, I love those answers, Bob. Thank you. And thank you for your work with Cellularity. You're pushing the boundaries of what we can do to regrow ourselves and become younger. And I'm grateful that there are people like you doing the work that's required, the deep science work, in order for us to all get access to stem cells and growth factors and things like that at an affordable level. So thank you.
Dave, thank you. And as one of my heroes, thanks for including me today.
If you like today's episode, you know what to do. Go out there and get some stem cells. Okay. Maybe you can just put that on your bucket list, because the cost is coming down. But if you are dealing with chronic pain, you're dealing with injuries that haven't healed, chronic conditions as you're aging, or even when you're young, this is something that should be in your list of menu options. It's really worth doing. And while you're at it, you certainly can go to Cellularity's website. That's CELLUL.
Yeah, let me get that, because by the way, Cellularity is intentionally misspelled as a spinoff of Celgene. It's one L. So it's CELULARITY.com.
All right. So there's a bunch of stuff you can learn there. And while you're at it, if you haven't pre-ordered Game Changers, my new book, check it out on Amazon or your favorite bookseller. Just search for Game Changers Asprey. And I have gone to the trouble of summarizing and in a statistically valid way, looking at all the answers to that question that you just heard, to figure out what hundreds of the world's top performers believe matters most, so that when you have that extra energy that comes from turning on your mitochondria, you know what to do with it to get the most results in your life. It's Game Changers. Thank you.